Okay, so now we have a basic understanding of these graphs, right? We can do the transformations, the same thing that we did starting back in chapter 1. I mean, if I add inside the function, that's horizontal. It's either right or left. Plus means left. So notice the original function would have been here, but by adding 1, it scooted it 1 to the left, right? 1 left. What do you do to the function when you subtract a number after the function? Down 2. So here's the original, and here's the transformed graph. Now, what did that do to the asymptote? Yeah, it's going to move the asymptote down 2. Now the asymptote is y equals negative 2. So what would you say is the range in this problem? Y is greater than negative 2. Okay. A common mistake that I'll see on a problem like this is you'll say y is greater than, or maybe you'll say y is greater than or equal to negative 1. It's like you're only thinking in whole numbers here. Somehow it's like starts here, but it doesn't start there. It starts infinitely close to the line y equals negative 2. It just doesn't touch that line. So don't think of it like y has got to be bigger than that whole number or integer. Yeah.
So, like when you're expressing, like the first one, hot left, when it moves to the left one, you would just move it to where it's almost touching the asymptote.
Well, you would take every point on here and move it 1 to the left, 1 to the left, 1 to the left. Did that affect the asymptote? Because this is the horizontal asymptote. You move a 1 to the left, doesn't make any difference anyways. Right? Yeah.
But that one, would you put y is greater than negative 2 or y is greater than or equal to? Because it doesn't touch it, right? So
if you're going to do a range, it's greater than negative 2.
Yeah, because
it can't be
equal, right?
Right. It can't touch that at all. Okay. What's the difference in the graph when you put a minus in front of it? It's in this book's terminology, it's a reflection in the x-axis. It flips it over the x-axis. Okay. Now here's one that we didn't see a lot of, but what happens when you stick a negative in front of the exponent? It's a reflection across the y-axis. So this exponential growth becomes exponential decay, which is kind of what we expect. One's 3 to the x, one's 3 to the negative x. That's how we express decay. No, it's only the vertical, right? This is a vertical translation, down 2. That's what moves the asymptote.